boranes and boranes. When the BH unit in the particular borane structures we called as boranes, whereas the BH unit is replaced by the CH unit is called as carboranes. So today we discuss about what is STYX number. STYX number. So it is a coded system which represents the overall valency bonding in boranes by 4 digit numbers in this. So X indicate number of BHB bonds. We already know the banana bonds. So T is indicate number of BBB bonds. Again, this is also 3 center 2 electrons. This is also 3 center 2 electron bonds. And Y is number of BB bonds. These are 2 center 2 electron bonds. Again, X is number of BH2 groups. It is indicated by the fourth digit. So are the first digit, second digit and third digit and fourth digits. So for example, you take the STYX number for various boranes in the basic structure. We are well known example is diborane. In the diborane we have BHB bonds, banana bonds is 2, and the BH2 groups is here 2 and 1 and 1 2. So again we write that STY representation. The S is nothing but BHB bonds. So here is 1 and 2. So 2 is BBB bonds. There is no BB bonds. You write 0. When the Y is BB bond, we have no BB bonds. So you write 0. BH2 groups. So here one is the BH2 group. This another one is BH2 group. We have 2. So the overall code is 2002. The next one is tetraborane. So in the tetraborane we discuss about again STYX number, whereas tetraborane the structure is like this. So the tetraborane, so how many BHPH bonds? BHP bonds 1, 2, 3, 4. So write BHP bonds is 4. BBB bonds, there is no any BB bonds, so you write 0. And Y is BB bonds, so only one BB bond is there, so you write 1. Again X is number of BH2 groups. So this is a 1 BH2 group and there is a 1 BH2 groups. These two are terminal BH. So it does not write that. They only ask BH2 group only. So you write 2. So the code is 4012. So first digit is indicate BHB. The second is indicate BBB bonds, and third digit indicates BB bond, and the fourth digit indicate it is the number of BH2 groups. The next borane is pentaboranes. So in the pentaborane the formula is B5H9. So is based on the structure only we can identify how many BHB bonds and how many BBB bonds. So here the 4 boron atoms located in the base are bonded to each other by 4 3-centered 2 electron BHB bonds like this. So this is the base. One is the BHB, another one is BHB, another one is BHB, another one is BHB. The second one is the boron atom located at the apex of the pyramidal is bonded to the 2 basal boron atoms. So this is the base like our pyramidal. So the top one is boron. So in this boron, again this boron is only related to 2 base groups. So here bond is basal boron atoms, 2 center 2 electrons BB bond. So only these two are only BB bonds. And again this molecule is containing close 3-centered 2 electron BB bonds. So the remaining, this boron is closely related to the like this only. So boron close related to BBB, 3-centered 2 electron bonds. So the representation of structure is like this. So this is nothing but so BBB bonds. It is a close related. So it is the position. So draw like this. So again the S is BHB bonds is 4 and T is BB bond only we have 1, and BB bonds. So this is one of the BB bond is 1 of the BB bond is 1. Oh, sorry, 1 plus 1 is 2, and the BB bond is nothing but this one. Okay, so only one BBB bond, and X is number of BH2 groups. So no, in the all are terminal groups only. So there is no BH2 groups in the particular pentaborane. So you write 0. The code is 4120. So here again, based on the structure, the molecule contain 5 terminal BH bonds. So in CSR exams they ask how many terminal bonds is there, how many bridging bonds is there, how many boron bonds is there, how many closed BB bonds is there in a particular structure. So here 5 terminal BH bonds and 4 are bridging BHB bonds and 2 are BB bonds and 1 is close related BBB bonds.